Hello there, and welcome to our unit on electricity. In this lesson, we're going to start with an investigation into static electricity. The word electricity comes from the Greek for amber, and it's a little chunk of amber here. It's part of a necklace my wife has. And so it is made of amber. And the Greek word for amber is electron. So why would all of electricity and electrons in the atom be named after a piece of amber? Well, people have been making jewelry out of amber for a long time, and what they noticed was if you rub it with a piece of cloth or another textile, that it would attract other substances, bits of hair and dust that would come along and stick to the outside. And so that attraction was related to the amber, the electron, and all sorts of other strange behaviors began to be associated with that as well. So where does electricity come from? Well, electricity and the electron both originate from the same word, of course, and we're talking about those bits of the atom that are on the shells around the nucleus, and it's the movement of those electrons from place to place by a variety of means that electricity is concerned with. So anytime that we're going to be learning about electricity throughout this entire unit, whether it's static electricity or the type that flows, current electricity, it's going to be the electrons that are running the show. The protons, the other parts of the atom, the neutrons as well, they're stuck. They don't go anywhere. So electricity has everything to do with electrons and their movement. So electrons can move easily through some substances and not so easily through others. So we have a few different terms to distinguish between those. The substances that electrons can move easily through are called conductors, and those that electrons have a hard time getting through are called insulators. And so you got a screwdriver here, which obviously has a strong metal shaft on it, and around that is a piece of rubber. And so if you're using your screwdriver here to drive a screw into something that happens to have an electrical charge associated with it, sometimes you might be putting, say, an electrical box into a wall. If you touched anything that happened to be electrified, which would be a whole bunch of errors that would lead to that, the electrons might flow along the shaft of the screwdriver, but that would be stopped by this insulator, this plastic or rubber handle that's on the outside. So electrical charge, as mentioned earlier, is all the result of electrons and their movement and the collective quantities of them that there is. So just a reminder, when you're going to have something with an electrical charge, it's because of the imbalance between the charges that make up the substance inside. So if there's an equal number of charges, so if we add an equal number of electrons to the amount of positive charge, then you're going to have an object that is neutral, no charge. If it gains some electrons, if we end up with more electrons by some means, which we'll look into later, you'll end up with a negatively charged object. And of course, if electrons are lost by whatever means, you're going to end up with a positively charged object. So we're going to look at ways in which we can charge objects or neutralize them. Just remember that whenever any of that happens, it's always electrons that are changing. We're not going to be adding protons or taking protons away. Protons are kind of stuck in the structure of the substance, right? All those ionic bonds and covalent bonds hold the nucleus and the protons in place. They don't get to move around, but the electrons do. And so that's what's going to give us our electricity. It's electrons going from place to place. All right, some basic laws of electric charge that people have discovered. First one is that if you have two objects of the same charge, they will repel each other. They will move away to opposite points as far as they can get from each other because there's a repulsion. a force that's felt at a distance without the objects actually touching. Same thing if the objects both have a negative charge. So it doesn't matter what the charge is. If they're the same, they'll repel. And conversely, the other side of this, which you already kind of know due to our ionic bonding, is that opposite charge particles or substances will attract to each other. And so you will see an adhesion or stickiness between objects that have opposite charges. Now, neutral objects can get a charge sort of temporarily if you bring them close to a charged object. So the process of doing this is called a charge separation, and you can kind of see an example of it if you charge up a balloon, say by rubbing it on your head, and then move it close to an empty soda can, you'll find that there's some attraction there. So if you give it a charge, let's say we give our balloon a negative charge here, it's got more negatives than positives, maybe a few positives, but of course, but way more negatives, right? So this is a negatively charged balloon. So you can have a neutral object, right, that has, equal number of protons and electrons. But if all the electrons are repelled and move away to the other side, then what's left is going to be, it'll have a positive charge on one side, right? And so they call this a charge separation, where within the neutral object, you have two charged sides. You have a negative side and a positive side. Of course, since this balloon is overall negative, I don't know why I made that funny shape, then there will be attraction here. This positive side will be attracted to this negative balloon, and you get that phenomenon of the can rolling toward the balloon. All right, another place you might have seen this is by taking a balloon, rub it against your head, and move it close to a wall. So in this case, let's say that you rub it against something that gives the balloon a positive charge this time. So we'll put a couple of electrons here. But overall, this balloon will say is positively charged this time. So what's going to happen is that all the electrons in here is going to be equal number of electrons. Let's see what we've got here. 2, 4, 6, 8, 10, 12, 14, 16 electrons. They're going to be attracted to the wall because of this positively charged balloon here. Maybe they'll be moved sort of closer to this area. And so you'll end up with this zone here that has a negative charge. And overall, this balloon here has a positive charge, and they will attract to each other. Okay, in order to tell if something has a charge, you might get a chance to use a device called an electroscope. So an electroscope has two metal leaves. They used to be made of gold. Now they're some metallic mixture. You can make your own at home if you like out of little pieces of aluminum foil. And what happens is that if you give this object a charge, the little ball at the top, if you give it a charge, say with a rod that you've charged, this is like a negatively charged rod, some of that charge will transfer to the electroscope, and you'll end up with these leaves having the same charge. Because they're metallic, they'll distribute the charge evenly. And if they have the same charge, they'll move away from each other. And that's a way to see whether or not an item has a charge. So in my example here, everything got a negative charge. And so the two leaves being negative will move away from each other. And you will have yourself an indication that your rod here, put a rod here as well, this rod here must be charged. Okay, there you go.